Hi, I am Muhammad Fakhruddin Muhammad Zainuddin. My name is Syahni bin Taha.
I'm Muhammad bin Zee bin Ridwan.
My name is Muhammad Faiz bin Samuddin. And my name is Muhammad Faizal bin Samuddin.
Our group were assigned to the question number 4 as our mini project, where we will have to write a program to execute an 8-bit addition from memory location 1000 and memory location 1001. After adding both data in the memory location, we are assigned to store the result in memory location 1002. If there is a carry on the data, we will have to display C-1 on the 7 segment display. If there is no carry, we will have to display C-0 on the 7 segment display.
So I'm going to show you the basic setup of the Dragon board and our program. First, we open the mini IDE. Then we open the project file. Then we have to make sure that the Dragon board and the computer is connected. So make sure it is connected. Then we build our program. Download our program S19 file. Then tap G0. That's the result of our program.
The first command of the program is include rack9 s12.h. This is required if you are using the Dragon board. Next is the org 1003, where this is the table for displaying 7 segment code for C-0. org 1020 is the 7 segment code for displaying C-1 on the 7 segment display. Our program starts at org 11000. MOV-B FFDDRB is the declaration for port B as output. The next is the declaration for port B as the output, and the declaration for port J as the output. bset PTJ will make the port J as ground. Next is load AA1000. It will load the data in memory location 1000 into CPU register A. Add A will add the data in memory location 1001 with the data in CPU register A. Store AA will store the result of addition into the memory location 1002. BCC means branch carry clear, where it will execute M2 if the carry is equal to 0. Else instruction on table N2 will execute, which is LDX #N, which means load table N into X. Load table N, which is the 7 segment code for C-1. Next, move B1 X plus port B is the code to display hexa value given in table on 7 segment. Move B1 X plus PTP will select which 7 segment will display the given hexa value data of 7 segment code. JSR D1MS is jump to subroutine D1MS, which is the delay for 1 millisecond for the code. Next is CPX, which will check if the table N has reached its end. if it has reached its end. Table N1 will repeat again, and table N2 will always be repeated to display C minus 1. If branch is C minus 0, which means that the carry is clear, it will load XM, which is the value for code 7 segment display that will display C minus 0 on the 7 segment display. The process is the same except that it will display C minus 0 on the 7 segment display.
I want to talk about the value in this memory. First, we need to push reset button, and it will appear here. We need to type load and enter, and download file to open. Here. To display the value in this memory, we need to press MD 100, 1000, and press enter. This is the value for this memory. If we look here, 34 plus 2A, it will not have any carry. So it will appear here C minus 0. If we want to change the value over here, we need to type memory modify 100, each memory 1000, and change to our new value FF example, and press enter. So it will change the value in 1000 address. To look back the value, we need to type MD 1000. Look, it will change the value. If we look here, FF plus A to A, we have a carry here.
Dah. Okay. To check data in memory location, we need to do the following step. First, we push the reset button. Okay, then we enter the following command. Okay, now we can see over here the sum of the location 1000 and 1001. There is no carry over here. Okay, then we proceed to see to how to display C-0 at the gameboard. First, we push the reset button. Okay, then enter the following command. So we have as C-0 at 7 segment.
Okay, for the change the memory modified memory, we must type load, enter, and download file. And type 1000 and value that to change. Example FF. And press enter. To display the total sum of 1000 and FF, to get the carry 1, type G and 1100. and the Dragon board will display C-1.